All right, so we are getting ready for our test tomorrow. We're going to start out by checking our test review. Remember, the first round, it's more just about getting the answers. It is Mr. Tate's handwriting, so if you can't read something, please ask. I know it looks a little different to me. But in terms of going over concepts and things like that, we'll do that after the binder quiz. So if you'd like to go ahead, get out your test review. We're going to break it up into top half, bottom half of each page. So here we go. And I'm just going to scroll this so we can get all the way up through number 7. So make sure you get that number 7 at the bottom as well. So 1 through 7 on the board. Check it out. Question? Yes, you may. Always. You never need to ask to move to see the board. And then FYI vocabulary on number 4. You might have just said electromagnetic force as opposed to electrostatic repulsion. Same concept, just that's a little more specific about the repulsion part of the electromagnetic force. But you have the right idea there if you have EMF. Pretty good here with the top half. Okay. All right, everybody got that number 7 because now we're scrolling down. Let's get the bottom half. Starting with number 8, and I will get the rest of 22 up before the end. I'm just trying to get the rest of number 22 on the board. There we go. And just looking down at 22, this highlighted word critical mass is not on your test, but we talked about the mass being too low or too high, and critical mass is kind of like that Goldilocks, just that minimum that you would need to get it going but not be a bomb. So, there's too little, the runaway chain, or the chain reaction doesn't start. There's too high, it's a runaway chain reaction, a bomb, and critical mass is that like in between. That would be the minimum to get it started, but not necessarily have made a weapon. Okay. So, FYI, that word's not on your test though, so don't panic. All right, then with that, ready to go to the back? Okay, so here we go, top half of the back, starting with 23 through 31. And just, I had to write in blue because my formatting got weird when I put it into OneNote, so, but it's all there. Okay. All right, and then ready for the bottom half on the back. Here we go. All right, so from 32, and then I will get the last blank on the 36. So here's 32 to 36. And then that last blank down there. And with that, we are ready to take our binder quiz. All right, so welcome back after the binder quiz. All right, question. Oh, we can talk about that at the end of class, okay? All right, so let's talk about your test tomorrow, though. Your test tomorrow is going to consist of 38 multiple choice questions, and that is your entire test. It is out of 100 points. I'm going to tell you, there's 2 calculations in there for half-life, and they count double all of the rest of them. So the 2 half-life ones count as 5 points, and everything else counts as 2.5. So that's where the 100 points comes from. They're not all equally spread out. The math ones do count a little bit more. Okay, so that will be your test. What are you going to get? Absolutely, you're going to have a periodic table, right? I will provide you with the periodic table. I have a laminated one that you guys use so that you can't use your own that has stuff that's written on it. Right? So I will give you a laminated periodic table that you can use to look up any elements and atomic numbers. You will be allowed to have a calculator because there's half-life calculations on there, right? Solving for A or A sub 0, so mine are yours. You will be given the half-life equation. I will give that to you. I'm going to rewrite it at the top up here just as a reminder. Whoops, A equals A sub 0 times 1/2 raised to the little t over big T. What you won't get, though, are what the letters stand for. So you do want to go back maybe right before you come in and remind yourself, hey, the A's, which one is the initial or starting, which one is the ending? Same thing with the T's. Remind yourself which one's the half-life, right? The other one, the time elapsed. Okay. And then, since I'm not collecting anything to grade, you will have all of the whiteboard material that you can write out any of your work. Okay. So anything you'd like to write out, you can for your test. So that's the test. Then there will be an extra credit question. And I've already told you it's going to be solving for either little t or big T in the half-life equation. So on Thursday of last week, I posted a video that explained how to do that. And if you looked at questions 2 and 4 from the half-life worksheet, that would be a chance if you would like to practice and see if you could get that. Right? But again, that's all extra credit. That's not required. If you need to get to that video from Thursday, you're going to have to go to the class history page. So you're going to have to get to my main page. I know a lot of you guys on your phones don't go there. Go to pages, go to front page, home page, and then go to class history. That's how you can get to that if you would like to watch that video. Question? Yes, you may. Okay. Somebody had asked, Mrs. Tate, if we just kind of memorize that last part of the equation, Can we just start with that and get our answer? I will give you some points for that, but you won't get all the points. To get all the points, you have to start from this equation and then get to one of the t's by themselves. Okay, it does involve the use of logs, but the video explains how to do it. So once you see it done once, then you can practice it. It gets done the same time. They're the same way every time. Okay. All right, and so with that, remember, my test reviews. The test review covers a lot of stuff that's going to be on the test, but I can't 100% guarantee that it covers everything. So we do always encourage you to at least read over your notes. Not that you necessarily need to make flashcards, but hopefully with multiple choice, you guys could figure stuff out. I will be upfront and tell you, I believe there are 2 questions that come directly from the articles and the answers that you had to write down. So you'll want to make sure that you've kind of looked over those, that you remember basics of how the nuclear reactor works, right? The breeder reactors that they talked about, some of the safety concerns with the reactors, right? That, and then the next one was the radioactive waste. You know, could you tell me, you know, which one of those were not type of rad waste, or what do we typically do with our spent fuel rods, stuff like that. Okay, and it would be in a multiple choice format. So with that, I will open the floor to you guys if there's anything from this review or anything else you would like to review from the unit. Now is your time. Meredith, go. Is there going to be a question on, Life 36? Okay, so I will go over it. I can't rule that out. Okay, it's possible. But let me go through how I went through and did this. This key really was important because, guys, immediately that means beta decay was never going to be one of my options because I had no way to show an electron in my drawings. All I had is a way to show protons and neutrons, not electrons. So beta decay couldn't have been any of these. All right, so then I said this was also important because you can start writing down some of the symbols for these. For example, this guy has 1 proton and 1 neutron. That means that would be a mass of 2 and an atomic number of 1, because the atomic number is the protons, the mass number is the protons and the neutrons. Guys, that's hydrogen. And then my next one is 2 over 1 as well. And then that made this guy right here, that's 2 protons and 2 neutrons for a total of 4 as the mass. 2 of those was protons. Oh, look, that was helium. And guys, this is our equation for fusion. Hydrogen fusing into helium is the most common example of fusion you will ever see. That's what the majority of the fusion on our planet is. All right, so then knowing that, guys, that's also 4 over 2He. You see that? But in this case, it's one of 2 products because here it's an alpha particle. So that's how I knew that this one, remember we said for alpha decay and fusion, they both have 4 over 2He. Except for fusion, it's the only product, and in alpha decay, it's one of 2 products. So there was your alpha decay. All right, so then we get down to our last pictures. Really, I was hoping for this one you guys would just see. They started out with this massive nucleus. I don't even know how many protons or neutrons, but we definitely ended up with 2 smaller ones. And we ended up with more neutrons. That was a really important part of fission, that it made more neutrons. Now, I'm not going to lie. I wish they had a neutron at the beginning, too, because fission's supposed to start with the neutron also. But I think they didn't want you to get confused with the bottom one. Okay? So then, the bottom one, guys, neutron bombardment. Neutron bombardment is anytime you take a neutron and you fire it at a nucleus. That's it. You fire a neutron at a nucleus, that's neutron bombardment. And if I actually did my counting, if I looked at my picture here, let me just color code. This neutron right here ended up right there. It stuck to it. So this made an isotope because now it's the same protons but different number of neutrons. You're like, Mrs. Tate, how does that compare with this? Because this one's supposed to have a neutron. Here's the deal. When I hit something with a neutron, that doesn't guarantee it's going to split. But if it does, if I do neutron bombardment and hit something with a neutron and then it splits, I can say, hey, my neutron bombardment caused fission. Then it became a fission reaction. But if I fire my neutron at it and it doesn't split, then it's not fission. But it's still neutron bombardment. So not all neutron bombardments result in fission, but anytime you shoot a neutron at something, it's called neutron bombardment. So having gone over that, does that help clarify with the picture. So we definitely have a big thing getting broken down into two smaller, too little putting together to make a big. So there's your fission and fusion. Here, this was your alpha particle. The key was helpful. And then here, hitting something with a neutron bombardment. All right, question.
In the neutron bombardment, do you isolate a neutron or do you just fire hydrogen?
So hydrogen, it's isolated neutrons in this case. There are isolated, we do have a way to do that. Okay, yes?
For reaction B, is the only way we can, like, in that same question,
Oh, in the same question, sorry.
is the only way we can identify it because of the two neutrons and protons?
Yeah, because of the alpha particle here. I mean, if I counted up, this is something bigger, and then what it did is it spit out this alpha particle, and that's what was left over. If I really wanted to do the counting and write out the equation, I could, but at that point, once I recognize that this is an alpha particle, then that should lead me to alpha decay. Yes?
How would you recognize beta decay in the picture?
You can't, because there's no symbol for an electron. I'd have to, in my key, have another symbol. So like, let's say a circle with a star was an electron. Then what would happen is you would have the same thing. So like, let me draw something out. Yeah, I made it pretty small, right? So I would start with that. It would go forward, and then guess what? I would end with that, except one of my neutrons would have turned into a proton, right? But I would have had total the same thing, and then plus I would have had one of those star things. Like, I'd have to have a new symbol. And so the beta particle would be a product, right? And then just remember, proton would turn, or a neutron would turn into a proton, because it splits whenever it does that. All right, that's a good question. All right, other questions, anything from the test review? We feel good on half-life calculations? We know how to put those in our calculator. I know, I just finished those worksheets. But some of you, I don't grade you on right answers, so I don't even know if your answers were right or wrong, but some of you, when you were writing out your work, there was a lot of times where it looked like you did your division of little t and big T right next to your 1/2. Man, if you put it in your calculator with the caret, that's fine. I'm not going to, get that picky on it. But just make sure this should be an exponent, right? This little t divided by big T. So if you're getting really, really wrong answers, that's one place you might be having an issue, is that this is an exponent. It's not just getting multiplied by 1/2. It's 1/2 raised to that. All right, we feel good on balancing and classifying. There's definitely going to be some of those. Ryan's got a question? Go ahead. Or Jake, sorry. I don't know.
Half-life equations, you have to write out all the steps, right?
Well, this is multiple choice, and I'm not grading any work. So you're going to get a freebie on this one, but it will come back, I promise you. That's probably why it was a little tough on the worksheet, but it'll come back. All right, so we're good with balancing and classifying. All right, then we just got a lot of just vocab and content. That's why reading back over your notes, getting a sense of those can be helpful. What's the difference between fission and fusion? How are we controlling those nuclear power plants? What's going on with that chain reaction, right? Where's the energy coming from? Why aren't we doing fusion here? We definitely going to have some equations, right? Picking out equation. It's multiple choice, though, so got to make that work. Some straight up questions, just do you know about alpha, beta, gamma? What they are, charge, mass, how they behave, what's their penetrating ability, what can stop them? Some very straightforward questions there. And then just ending up, again, with some more definitions and those forces about what makes something stable or unstable.
So should you memorize this chart?
Yes, you need to know everything in that chart. You need to know their charge, their mass, their penetrating ability, what the particle symbols are, what they're made of. Yep, for sure. All right, other questions? Anything from the unit? Okay. All right, then just as a reminder, this will end up being the last test of the quarter, because while we're going to start Unit 4, we won't be able to finish it before the end of the quarter. But the test actually will be the very next week, right after the end of the first quarter. So last test for the quarter that we want to have a good showing on. However, there will be another lab this quarter. So I know some of you in your lab quiz grades are hoping to get a little boost there. So that should be coming as well. All right, last thing I'll say here, just FYI, because of the assembly second period's doing a completely different thing. So when you go into Canvas for the next 3 days, make sure you're paying attention. They're separate things for first and fourth period versus second period. So make sure if you need to find stuff, you're focusing on just the first and fourth period stuff for the next 3 days in terms of videos and agenda and all of that stuff. Okay? All right, so then with that, I just have a little extra review stuff. Right? Can't hurt to hear a little bit more about nuclear chemistry stuff that's going to be on your test tomorrow.